Greetings, class. This is yet another video about confidence intervals. Make sure that you've already watched the first video discussing the introduction of confidence intervals and what they are. I've placed this on Blackboard, this handout, this exhibit called Calculating Confidence Intervals. These are the formulae that can be used to calculate confidence intervals. As a refresher, a confidence interval is an interval within which the mean's in the middle, all right, and it's a lower limit and an upper limit, and with the mean in the middle, lower limit and upper limit with the mean in the middle, and it is within that interval that we can be confident to a certain degree, to a specified degree, not a certain degree, a specified degree, that the true population mean falls. So before we get to the calculation of confidence intervals, I just wanted to define specifically what these formulae are. First of all, LL, as you may have already guessed or hopefully know from your very close reading of Chapter 7, LL stands for lower limit. That is the number that will be lower than the mean, the sample mean, so on the left side of the mean, okay? UL, as you can probably already guess, stands for upper limit. It is the number that will be on the right side of the mean, all right? So lower limit's going to be on the left side of the mean, upper limit's going to be on the right side of the mean. What do you think's right in the middle? The mean, right? So let's start with lower limit. To calculate the lower limit, here's what you need to do. LL, lower limit, equals sample mean. Hopefully you're very familiar with that number, the sample's mean, minus a t-value, and that t-value is going to come from the t-table. That t-value is going to come from the t-table, and we're going to multiply that t-value by S sub x bar, the standard error for the sample. Hopefully you're very familiar with what the standard error is. It's yet another measure of dispersion, just like the range, the interquartile range, the variance, the standard deviation. I have a whole YouTube clip devoted to, actually more than one, devoted to the standard error and how to calculate it and what it means, all right? So the lower limit for the confidence intervals, the lower limit is the sample mean minus a t-value from the table, times the standard error of the sample, okay? And just as a refresher, though you probably already know this, the standard error for the sample equals the standard deviation divided by the square root of n. Sorry, I just kind of cockeyed there. The standard deviation divided by the square root of n. The upper limit equals the sample mean plus, that's not a t-value, that's a plus the same t-value from the table times the sample's standard error, S sub x bar, and that's how you find the sample standard error. So confidence intervals, to calculate confidence intervals, we need to find a lower limit and an upper limit. We're going to build intervals around the mean, and within that interval, we can be specifically confident to a specific degree that the true population mean falls. Okay? So lower limit is the sample mean minus a t-value from the table times the sample's standard error. We would do that math first. The appropriate t-value from the table times the sample standard error, and then take the mean and subtract that product from it. The upper limit is the sample mean plus that product, the t-value plus the sample's standard error. The next segment will walk through an example, including the drawing that needs to happen as well. We'll walk through an example of building confidence intervals.